Welcome to today's webinar entitled Key Performance Metrics for Energy and Facility Managers. My name is Billy Zadig, Manager, Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage under the Continuous Learning tab later today. Professional continuing education certificates are being offered for today's program. Those who indicated they wanted a certificate at registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. At this time, it's my pleasure to turn this over to Bob Knabler, our speaker for today. Bob, take it away.
Thank you, Billy. As Billy noted, my name is Bob Knabler. I'm a member of the EMA. I'm actually on the board of directors. I'm a past president of the board. I actually work in the side for teaching and helping to present and teach the EMA workshop as well as other different webinars. Today, we're going to talk a little bit about key performance metrics for energy and facility managers. And kind of a brief overview, we're going to start out talking a little bit about energy costs, the importance of establishing baselines, and then using those baselines not only for tracking your facility, but through different benchmarking tools to kind of compare it against peer facilities. We'll also talk briefly about separate energy performance indicators, a little bit about water and waste tracking, and then a little bit on the maintenance side, dealing with facility condition index and also asset maintenance matrix. And then we'll wrap up talking a little bit about IEQ and about greenhouse gas emissions. We understand that metrics are very important. And why are they important? Well, as you can see here from this quote, William Kelvin was born in Belfast, Ireland. He was a physicist, a mathematician, and a scientist, probably best known for developing the absolute temperature scale, which a lot of people understand, the Kelvin scale. And also he chaired the committee that actually came up with the electrical terms for volt, amp, and ohm. But what you see here, he states, what is not defined cannot be measured. What is not measured cannot be improved, and what is not improved is always degraded. And I think most people that deal with facilities and buildings and their systems would agree with that. Over a period of time, whether it's pieces of equipment, whether it's controls, whether it's other portions of the building itself, will tend to degrade and weather or fall out of calibration over a period of time. Corporations and institutions really need to define their goals, and we're seeing more and more of that in today's society. As you see corporations with these new ESG guidelines, you also see this move towards people developing energy roadmaps or energy master plans, and sometimes they're a part of a larger sustainability plan that they may have, and the need with those plans to then convert any goals that they have into some sort of a measurable metrics. Right? And those metrics, as we say here in the first bullet, they need to be selected based upon what the assessment level is. Are you dealing with a specific system? Are you dealing with maybe a process, just an individual facility, or maybe something larger like a campus, or maybe even an entire corporation? Metrics, for the most part, need to be selected to track performance over time. And what's really important here is to understand that metrics may vary based upon who the audience is. Operational level indicators would be very appropriate for like facility managers, the people that help make the building and their systems run. Site level indicators may be for that management level right above that may be looking over an entire campus or portfolio of building. And corporate level indicators would be upper management, and they may be looking at something that says, okay, we would just want to see at a corporate level how all of our facilities are doing. So that's what's really important, to establish those metrics early on. Key metrics are really critical for managers, and we say that in terms of they have to understand the current performance of their facilities, and then they have to use that data to help establish the goals, to gain some insight for strategies and budget decisions going forward. And that's true whether it's simply energy or other sustainability initiatives, whatever they may be. Data without critical review and analysis is really useless. And as we say there at the bottom, what's not properly measured and analyzed cannot be managed. It's sort of amazing in the work that our company does when we go out and talk to people that have the capability of trending, and maybe they do trend through their building automation system or building management system a number of points, but how often do they really review those points? How often do they review the data that they get? You know, is there really a rigorous process, or at least a periodic process, to look at that? Even with utility bills and going through that. We had a case where we went to a hospital one time to do some analysis. Actually, it was going to be retro commissioning, and we asked for utility bills, and the facility manager said, I never see them. They go directly to accounting. Accounting pays them, and I don't. And we said, that's you need to take a look at the data that's actually given to you on a monthly basis, if not more frequently. So we'll start talking about energy usage. We want to talk a little bit about, you know, monthly usage, peak energy cost, utility analysis. So really the basics, a lot of people look and track according to, you know, how much energy they use or whatever their utility is, whether it's electricity or gas, or maybe they're being served by some district heating or cooling system, in the consumption, whether it's in kilowatt hours or therms, on a per square foot basis. They look at it, you know, how much is my building consuming, or maybe in cost. But you know, you must understand that energy consumption and costs are going to vary, because again, costs over time are going to fluctuate depending upon the rate structure that you have and what you're being charged by the utility. That total energy usage, which you see in the middle bullet there, you know, that relates back to that energy use intensity, energy use index, which we'll talk about in a little while, where we're measuring really the total energy used, you know, in kBTUs per square foot per month. But other utilities are important as well. You know, whether it's portable water, you know, maybe you have reclaimed or gray water for usage. And then again, the water use intensity, which is really the companion measurement of the energy use intensity, often measured in gallons per square feet per month. So the other thing that people really look at up front is peak electrical usage. You know, what percentage of the total utility costs are attributed to times during peak demand? You know, what is the demand, you know, peak demand in kW per square foot per month during peak utility rate hours, and really a companion to that, what is it in dollars per square foot per month? And then finally, utility energy cost index, which is simplistically the total utility or energy cost for a facility or company, usually expressed in dollars, and then as a percentage of the total revenues. And this is something corporate often likes to see, is, you know, how much are our expenditures, you know, utility wise, compared against the total cost of our facility, or maybe against our revenue. So that's what's important going forward. Utility bill analysis is also very important. Again, we talk about the fact that it's important to take a look on at least a monthly basis. A lot of times you can get the data through your utility company on a more frequent basis. You can sometimes get real-time data, and being able to identify as quickly as possible if there is an anomaly, if something perhaps has happened. You know, if somebody has left equipment running that should have been cycled off. You know, the ability to audit bills, to review various rates, you know, that's important as well, and identify any options. We do the Energy Management Association, we have a separate presentation that we do talking all about utility rate structures. There's a lot of things going on in that field right now, a lot of not only incentive programs, but a lot of innovative programs with respect to how utilities are billing their clients. And what's also important is it helps to assist in forecasting future demands for clients' energy roadmaps or master plans. We get involved with a number of clients who have got major additions or expansions of either a specific site or maybe at a corporate level, and they want some sort of an energy roadmap to kind of forecast not only what our utility bills will be, but how much additional operational cost are we going to incur. We had one case where one client was adding almost 2 million square feet over a 3 to 5 year period, and they wanted to know, okay, what impact is that going to be on our operations and maintenance budget as we go forward. Again, this rate comparison and sub-metering, it's something that you need to take a look at. Like I mentioned earlier, we have a separate presentation that we do. But what's important are a couple things here. Again, there's a lot of utilities out there that are being very innovative in the different types of rates that they're offering to clients. And not, used to have flat rates or maybe tiered. Now there's a lot of different time of use rates. Some utilities will allow the installation of multiple meters, particularly if you've got electric vehicle charging stations. They'll let those be separate from the meters for the balance of your facility. You've got the net metering if you have on-site generation, renewable generation like solar PV panels. The rate database that I offer there, and I've showed you the link, there's actually a database that keeps track of all the various utility rates that are out there by the various utilities. And it can be searched by zip code, whatever the location of your or your client's facility is. It can also be searched by utility company and be, again, sub-searched or, drilled down into whether it's commercial, residential, industrial type of rates. But as I mentioned, there's so much going on. And to give you an idea, recently we discovered, out in California, they had that Assembly Bill 205. And what that did is they're going to start the three major utilities out there: San Diego Gas and Electric, Southern California Edison, and Pacific Gas and Electric. They're now mandated to offer rates based upon individuals' incomes. So at least at a residential level, the fixed utility charge is going to be based upon your income level, and then added to that will be a cost of whatever your consumption is. So there's a lot, as I mentioned, going on, and it also implies that you need to take a look at sub-metering and identifying, again, what some of the major loads are. And a lot of people may not recognize the fact, but the last couple of iterations of the major energy codes, and again, you've got these ASHRAE 90.1 and the International Energy Conservation Code, which are really the basis for most state and local building codes, energy codes, at least that portion of the building code, the energy part. They have included within them sub-metering requirements, and they mandate that, for new facilities, you've got to be able to meter separately the HVAC systems, interior lighting, exterior lighting, plug loads, and even process loads. So this is now, whether it's done through individual meters or through some power monitoring system, whatever the case may be. I mentioned earlier about energy balance, energy baseline. So this basically establishing your energy baseline is very, very critical, okay? And the International Organization for Standardization, which is ISO, the ISO 50001 Energy Management Standard, requires that energy baselines be developed, and they basically have 6 steps. First, whether it's to decide on the boundaries, whether it's buildings, campus, whatever the case may be, establish the baseline period, typically, which is a year, gather the energy data, determine the factors that heavily influence the energy consumption, and then calculate the energy use intensity and track and report the progress. So again, gathering the data, monthly energy bills, at least 3 years. I know we've spoken a couple times, I've had questions brought up. There are anomalies if you go back, 3 years at this point, because again, 2020 and 2021, if you're dealing with any facilities that were heavily impacted, like office buildings by the pandemic, that data is not going to be representative of the years prior to that, or maybe even now after that. So there's going to have to be some sort of regressive analysis. There's got to be some sort of adjustment to come up with what is really a true baseline there. You can gather additional data by going out, doing sub-metering, if it's available through the BAS or through your power monitoring system, or you can install data loggers. And then you want to establish that load profile. And you really want to do that by utility, or by fuel source, and you want to correlate it with any affecting factors. And you want to do it typically on a monthly basis. And the tools you can use, whether you want to use spreadsheets, if you want to actually develop a computerized energy model and use 8760 weather data, it depends upon you, your client, and what you're trying to achieve. Energy balance is typically a 4-part process. Identify the baseline energy usage by the fuel source. As you can see here in the upper graphic on the right, we have 3 sources: electricity, district chilled water, and gas. Define the energy balance for each of those energy sources. In other words, what is the typical profile of consumption and use over an annual basis? Subdivide the largest energy consuming systems, and even subdivide even the largest consumers. For example, in the lower graphic you see we've got electricity, and it's been drilled down for HVAC into fans, chillers, pumps, etc. And then you establish a baseline from there. The factors affecting energy consumption, again, I think most people understand and know those, whether it's weather, degree days, seasonal activities, depending upon the facility you're looking at, if it's involved in retail or perhaps a school with education where there's extended breaks. Occupancy or occupants' behaviors could have an effect. Adjustment in production levels. And then any energy intensive operations. If you have labs, data centers, any kind of pharmaceutical manufacturing or other manufacturing, and then what the internal load schedules, if you have 2 shifts or 3 shifts, etc. Mentioned earlier about the energy use index, and again, here's a very common equation. It's pretty easily calculated. It's the energy consumed measured in kilobTUs within a building divided by its total square feet. So again, if you have several different fuel sources, you really need to convert those into kBTUs. If you've got therms for gas, if you've got kilowatt hours for electricity, and then once you get into kBTUs, divide by the building area, and that gives you your energy use index. So a lot of people have heard the term energy use intensity or energy use index. It is, as you can see here, the metrics the most common for measuring and evaluating energy consumption within the site or within the building. And you kind of see by the graphic on the right, that orange arrow, it really confines itself to what energy is being consumed on the site or within the building itself. But there's basically a companion calculation to that called source energy use intensity. And what that does, it reflects back to really where the source of any purchased energy is coming from. Most commonly electricity, and basically it reflects the power or the that's being consumed, the energy being consumed for the generation, the transmission, and then whatever delivery losses there are. And that's done those adjustments from EUI to SEU are typically done through multipliers. And what you have here on this sheet is a table that reflects really, I think, the most current multiplier table from Portfolio Manager. We'll talk about Portfolio Manager in a second, which helps to adjust based upon what your energy or fuel source is from site to source energy. For example, if you were purchasing electricity from the grid, the US ratio, you'd be multiplied 2.8 to whatever your site was. And you can see the other adjustments there. We don't have time today to go through the calculations. We have other presentations we do, and I'm actually putting one together where it'll be nothing but sample problems and calculations reflecting a lot of the material that's in this one. We'll actually go through and do those calculations and sample problems. But these two tables, which are used again through Portfolio Manager, have the data which has been compiled from what they call the Commercial Building Energy Consumption Survey, where they've gone out and they've gathered energy data, consumption data, and you can see the two columns there, one for site EUI and one for source EUI for the different categories of facilities. And you can kind of see there whether it's education, public assembly, you've got healthcare, you've got retail, you've got office buildings. And these are basically the averages that they have. And this is where you get, when we move into benchmarking, to kind of compare your facility once you've calculated your baseline and your EUI against the others. So again, just as a quick recap, baselining is, again, once you've established your baseline, if your goal, and we had one client whose goal was to decrease his average energy use intensity for his portfolio of buildings by 10% within 3 years. That was his goal. So again, he's going to be comparing over a period of time. So baselining is you're measuring relative to your specific baseline year to see how you've improved. Benchmarking, on the other hand, compares the performance of your facility to some average, like the data I showed you in that table on the last slide, or to some established best practice level against a peer group. In other words, how does my building compare against similar buildings, by my, companions out there? How does it compare? Is it more efficient? Is it less efficient? Am I about average? So talking about benchmarking, as far as metrics go, we're going to talk about 3 different ones here. And the first one, which is by far the most familiar, I think, to most people, is Energy Star Portfolio Manager. And again, this is the one. These are all free. They're all available out there on the internet. You can go out there. The EPA, the government's Environmental Protection Agency, they're the ones that basically monitor and are in charge of Portfolio Manager. They're the ones that maintain the site. They have the data that's out there. You can go out and insert your data if you want to do a comparison. But what's interesting about Portfolio Manager, most people know it as a benchmarking tool for energy, okay? But as you see here on the left in my narrative, it's not only used to track energy, it can also track water use, waste and materials, and even greenhouse gas emissions. And we'll talk briefly about that as we go through. And what's interesting is once you start doing benchmarking for your facilities, it can help you identify any buildings that are really underperforming. It can help you identify which ones you need to tackle, okay? It can also help set any budgeting or investment priorities, going forward for capital improvement, capital budgeting. And so that's one of the benchmarking tools. Basically, the scale is 0 to 100, okay? And again, the higher the number, the more efficient your building. in your comparison. Another tool that's out there, and this one is actually basically offered by DOE, the Department of Energy, is the Building Energy Asset Score. Again, you can go out there, the data is available out on the internet, you can take a look at it. It also uses energy use intensity, but it estimates the energy use intensity by you modeling the building. Basically, you put in various characteristics of the building itself and its energy systems, and then it makes some assumptions about the operation and about the weather. And then using all that data, it creates a score, again, ranging from 1 to 10, okay? Which 10 being the more efficient, 1 being the least efficient, you know, with respect to your score. The third one we're going to talk about briefly here is ASHRAE's Building Energy Quotient, or BEQ. And the BEQ program, ASHRAE's had that for a while. They came out with it probably about almost 15, 20 years ago. And it was kind of a label schedule A through F, and it really kind of fell on its face. They were trying to generate something that was a competitor to Portfolio Manager. They pulled it back, they reworked it, and now it's much better. They brought it out. As you can see here by the write-up, it helps to assist in the preparation of a level 1 energy audit, making various recommendations. And it really can generate 2 scores, as designed and as in operation. And the scale on this particular one is 0 to 200, with 0 being the most efficient. Actually, it'd be a net zero building, and 200 being the least efficient. And you can kind of see here by the graphic on the right, you know, that those 2 scores may vary a little bit. A score of 100 would be average with respect to the BEQ. One of the things about the BEQ program that ASHRAE, you know, tries to purport is the fact that while owners can input the data themselves with respect to Portfolio Manager and with respect to, you know, building asset, they really require on BEQ that a certified, either somebody that's a building energy manager, he's got some level of certification from ASHRAE, or like from the Energy Management Association, an EMP, or a professional engineer within the jurisdiction of the building, needs to input the data and provide a level of QA/QC. So they basically purport that there's a little bit more level of credibility and quality control with respect to BEQ. But with that is the fact that it's probably the most expensive, because you have to have a third party engaged of the 3 benchmarking tools that I'm showing you here today. Beyond the benchmarking tools, there's also what was known as energy performance indicators. These are just individual indicators depending upon the type of building and whatever the client, you know, may require or may need. So again, going back to the ISO 50001, they define an energy performance indicator as a quantitative value or measure of energy performance as defined by the organization. It's important to set appropriate energy performance indicators for monitoring and measuring the energy performance. So for example, it could be BTUs per unit of product if you've got a assembly plant, BTU per pound of product for a manufacturer, BTU per number of beds occupied, you know, for a hotel or a hospital, or power usage effectiveness for data centers. So once again, there's a wealth of information that's out there. The EPA had worked with industry, and they've developed sector-specific benchmarking tools, which they call performance indicators. And what you have here at the bottom in these 2 columns these are performance indicators that they've helped develop for these different industrial processes. And the templates are out there. They're available. You can go out, download them, along with the instructions on how they're being used. And I basically downloaded a couple of templates just to kind of show you. And the one for automobile assembly, again, it's used to evaluate facilities that have the criteria that you see here listed for body welding, painting, and various assembly processes. And again, it triggers on the number of vehicles being produced, what type of vehicle, you know, is it a passenger car, sports utility, whatever. And then as you drill down and you put the information in, again, whether it's electricity, whether it's gas or therms, you know, per vehicle, you input it, and then it kicks back summaries, you know, with respect to statement of energy performance. Now, again, these are the blank templates, but if you had a facility and you put in the information, this is kind of what kicks out. And they've got this for all those different industrial processes that you saw there, you know, as we were going through. Beyond that, you know, I mentioned hospitals, and again, there's several measures that are also used to track performance or metrics in hospitals. Occupied day beds, okay, are also called patient days, the number of days or part days for all patients that were admitted. Separation is defined as a formal process which records the completion of an episode. But the bottom line is, again, various industries, various institutions, corporations, etc., may have special indicators that they track, whether it's for energy performance or some of the other things that we'll be talking about. And it has to be appropriate and something that they track on a regular basis and helps to give them an idea of where they're headed and how they're performing. You know, one of the ones in data centers, and whether you've come across this or not, is what they call power usage effectiveness, or PUE. And PUE basically is the division. It's the total power into the data center divided by the IT equipment power. So as you can see here by the graphic, all the power into the data center represented by the green arrow divides itself into the supporting infrastructure at the bottom and the power to the IT equipment up above. And to give you an idea, probably about 15 years ago, if you had a data center that was maybe 1.6, 1.5, today there's been great strides made, and the average PUE, now again, a perfect PUE would be 1.0. All the data, or I'm sorry, all the power input to the data center would be strictly used for IT equipment. That would be, actually Google's average PUE is 1.1 right now. At the bottom, I've shared an additional reference from ASHRAE. It's standard 90.4-2022. That's a standard for data centers. It's basically a companion standard to 90.1, to give you an idea. Water and waste tracking. I mentioned earlier that Portfolio Manager also gets involved in water and waste tracking. Again, it's an additional benefit that's offered by the EPA. It shows, I'm showing you here, that Portfolio Manager permits tracking from 4 different sources. You can kind of see they're listed: municipally supplied potable water, reclaimed water, well water, and then any of these other sources at the bottom, you know, harvested rainwater, you know, gray water, etc. And then again, performance indicator, and we talked again about the companion to the energy use intensity is, for any building, water use intensity, which is gallons per square foot. Again, that metric of measuring consumption against the area of the building, size of the building. But you can also have other performance indicators, just like we were talking about energy performance indicators. It could be water consumption or use per bed, gallons per bed per day for a hospital. gallons per worker per day for like an office building based on the number of occupants, gallons per room per day for a hotel. So these are available as well. And again, companion to the water is, again, waste tracking. Waste tracking is out there as well. And it permits, as you can see here, 29 different types of waste materials. And you can divide up in your tracking between recycled, composted, donated or reused, or then simply disposed of. And then when you dispose, it can be further categorized. You can drill down into whether it's disposed into a landfill, whether it's incinerated, whether it's used perhaps in a waste to energy facility or other. And the graphic on the right, which I clipped out of, again, Portfolio Manager, kind of shows you all the 29 different materials that you're allowed to track, in your facility, which is important. And with respect to how it's measured, they typically do it by volume or weight. You can go out there, again, they give you templates and they help walk you through how it would be done. Now kind of switching from more on the consumption side to facility condition and asset maintenance metrics, I want to talk a little bit about Facility Condition Index, the fact that it's a benchmark used in the facility management industry, really launched in 1991, primarily used, in the U.S. by government, education, housing, and other organizations. And again, by its most basic definition, it's defined as a ratio of a current building's required renewal cost to the current building's replacement value. So you add up the cost of any deferred maintenance or repair or any replacement due to deficiencies, divide that by the current value of the facility, take it times 100, and that's your facility condition index. So if you were to, and again, to come up with those numbers, you may have to conduct a facilities condition assessment where you actually go out, walk through, it's almost like a retro commissioning, but you go out, you assess the condition of the facility, its systems, its equipment, and so forth, and assess a value to bring it up to where it needs to be, okay? And then at the same time, the organization has to put a value on what would it cost to replace that facility. And a lot of times that may be done on a dollars per square foot basis, okay? But again, the accuracy depends upon the organization and what they're trying to do with this facility condition index. But, and I've seen different scales, but this is one that's fairly commonly used. So, for example, if you had a facility that you decided was going to cost $10 million to replace, you've got some building, it would cost $10 million to replace it, and you've gone through and you've calculated that the current repairs or deficiencies would cost $300,000, well, that facility condition index would be 0.03 or 3%, so it would fall in the good scale. Conversely, if you calculated that the replacements would be 1.2 million, that would be about 12%. On the scale, it'd be poor. There's also, I want to talk briefly about asset maintenance matrix, and this is a group of matrix that the facility manager would use to help. A lot of times these can be generated and put out by the CMMS system. They can perform these functions, but you see a list here of 7 different issues: mean time between failures, mean time to repair, etc. We're going to kind of scroll through these and talk about them briefly. So again, mean time between failures allows one to anticipate what's the future breakdowns by looking at whatever that asset's failure was and its maintenance history. So how long has it been in use minus any unplanned downtime divided by the total number of breakdowns. So mean time between failures. Mean time to repair analyzes what a technician's response time is to resolve a breakdown. So the total maintenance time divided by the total number of repairs. So the mean time or average time to repair. Overall equipment effectiveness. So again, here we have, this is a measure of an asset's effectiveness based in 3 categories: availability, performance, and quality. So a perfectly efficient piece of equipment would have an OEE score of 1. Okay. So it would always be available. In other words, its performance, its actual cycle time aligned with its planned cycle time, and valid pieces would be equal to total pieces produced, and it would be 1. But overall equipment effectiveness, a lot of times this is used on the process side. Cost of asset maintenance, one way is to analyze is what's the cost of the planned maintenance to the unplanned maintenance. Another way is to calculate the difference between the budgeted cost and the actual cost for performing the maintenance. Again, expected cost minus actual cost. Cost to repair, or I should say cost to replace versus cost to repair. So again, anytime one is considering investing more time and money into a deteriorating asset, it's important to consider the cost. So again, we've got this cost to repair. What's the annual expected cost of maintenance on any existing equipment? Compare that to the cost to replace. So what's the replacement cost divided by that asset's lifetime plus its expected annual cost of maintenance? And then we have the unplanned maintenance percentage. So this is one thing to kind of give you a view or an idea of how well your proactive planned maintenance program is working. So again, tracking unplanned maintenance, which every facility is going to have some, against their preventative maintenance plan. An acceptable amount of unplanned to planned maintenance usually is in the 10 to 20% unplanned versus 80 to 90% planned. So, hopefully if you've got a good preventative maintenance plan and you're very proactive, the amount of unplanned is going to be a smaller percentage. And then finally, this work order resolution time. Again, tracking work order resolution, total time to resolve all work orders divided by the number of work orders. And again, this helps the O&M staff and the facility manager, okay, to basically assess, okay, what the resolution time is on the work orders. He can maybe adjust and prioritize certain critical repairs. And he can also take a look and see as far as goals and if there's any adjustment in seasonality. Is there a certain time of year where there's more work orders or where it tends to take more time? Moving from asset maintenance into IEQ and building comfort index. Again, this is something that's very important because it affects occupants of the building, and productivity. So again, this relates to the health and comfort of the occupants. And you can kind of see here, these are the 6 items that most people associate with IEQ. Obviously, number 1 is the indoor climate, temperature and relative humidity. Associated with that is airflow rate. You could also have carbon dioxide levels or the amount of ventilation required. Electroclimate, again, as we have more and more of these Wi-Fi systems, and you have more and more different frequencies and electromagnetic waves, electromagnetic frequencies that are out there, EMF, a lot of people are susceptible to that. So, I mean, that can have an effect on the indoor environmental climate. Pollutants, again, biological, VOCs, dust, the amount of filtration that one may need, and then finally, light levels. The health effects from poor indoor environmental quality can be as little as irritation, maybe to eyes and nose, but that again can have an effect on productivity, headaches, and then as much as even heart disease and cancer. depending upon what people are exposed to over time. So what are the metrics to monitor IEQ, indoor environmental quality? Well, again, number of sick absences per employee per year, or maybe per square foot, number of comfort complaints per employee per year, percentage of time the occupied facility is within temperature and humidity set points. And then there's different groups have developed their own weighted averages for indoor air quality indices. And for example, Breeze Technologies has an overall, what they call an indoor air quality index, which takes into account temperature, relative humidity, CO2, and VOCs, volatile or organic compounds. And finally, you can have corporations that may have their own productivity metrics, and those productivity metrics may be aligned with or looked at with respect to indoor environmental quality, and see how it aligns. Then we want to talk briefly about greenhouse gas emissions and carbon footprint. So again, this has become more and more important to many, not only the government, many institutions, many corporations now, again, as they move towards net zero or move to improve their environmental scores. They're actively identifying, assessing, and trying to reduce their greenhouse gas emissions. And really those emissions are from primarily these 6 compounds that you see here, from carbon dioxide down through sulfur hexafluoride. And again, there's a protocol that's been established, what they call the corporate standard, identifies greenhouse gas emissions and defines them into 3 different scopes. Scope 1 is any direct emissions and from any owned or controlled sources. Any direct emissions associated with your facilities equipment or systems, any vehicles that's owned by the corporation. Any indirect emissions are from the generation of purchased energy. So again, indirect emissions that would be assessed to you would be from those at the power plant for the energy that they generated that you purchased, okay? So obviously, those individuals that may have on-site solar PV or on-site power generation from renewable energy, or have been in a position to purchase, maybe through a power purchase agreement or some other way of purchasing renewable energy, that's going to help them with any indirect emissions. And then scope 3, and this is where it gets very difficult and it's hard to track, are indirect emissions, okay, that occur, except for scope 2, either throughout the value chain. This is both upstream and downstream in products that your particular company purchases or produces, and ships out. So this is a very good graphic, and you can kind of see I'm giving credit here to Daniel Overbay, but you kind of see from the reporting company, the direct scope is the green arrow in the middle from the company's facilities and the company's vehicles. Those are direct emissions. The indirect emissions, okay, for scope 2, you kind of see it from the light gray arrow on the left, which is again purchased electricity or steam or heating, anything that has emissions associated with it, but basically you're purchasing that portion of the energy. And then 3 is everything else, the upstream activities and downstream activities, and you kind of see there in the 2 dark blue arrows that are there. And up above are the 6 primary emissions that we're talking about with respect to the compounds. Data needed to measure GHG emissions. Again, what the activity is, this is just a partial list, but the activity, what the unit of measurement is, you can kind of see here on the 4th line, fuel usage for company vehicles, gallons of fuel bought. Okay, and how do you track that? Well, through invoices or receipts. Okay, company travel, maybe miles flown. Okay, So this is the kind of data that a company needs to track to equate to that metric. But once again, and again, this is more of an estimate thing, but Portfolio Manager can help out here. They basically allow users, as it says here on the left, to create location-based and market-based greenhouse gas emissions estimates, okay? And I've kind of given you a blank template here, and you kind of see the categories within that template. And what can happen is you can apply, if you're the owner, you can go in and you can apply historic emissions factors, or you can forecast emissions based upon different user-defined assumptions. There's a capability of going in there, putting in some critical data for your company or your organization, and it will help you generate what your estimated emissions are and give you at least a baseline to track going forward. A lot of those metrics then are converted into what's called carbon dioxide equivalents. Carbon dioxide equivalent is used to measure and compare, as it says there, emissions from greenhouse gas based on how severely they contribute to global warming. So you can kind of see there, again, I have kind of a printout there from emissions on a typical building on the right, but it kind of gives you an idea of being able to track your metrics. Again, Portfolio Manager is more, as I mentioned earlier, more than just tracking energy. The EPA has really broadened that, as I said, into water, waste, and being able to even greenhouse gas emissions. So the final thing I want to talk about today briefly are, where are we in terms of facility and energy management markets? Because this has really become a big emphasis for, again, a lot of corporations, a lot of institutions, and a lot of government entities. So just to give you a feel for how big the markets are, we'll start out talking a little bit about facility management services. So facility management services, and now we're talking about companies like Jones Lang LaSalle, CBRE, Cushman & Wakefield. The global market in 2022 was 1,260 billion. That's the global market. And it's projected to almost double to 2031 billion dollars by 2030. And one of the reasons is people see it, the owners see it as it increases the value of the buildings by offering various maintenance supports solutions. And these services can be broad-based. There could be hard services, physically associated with civil, electrical, mechanical. There could be soft services like you see here, cleaning and landscape. And then there can be management services dealing with management of the energy, the utilities, even maintenance planning and control. So again, whether it's outsourced or in-house facility management, these services, the dedicated team, the dedicated effort put out into managing facilities continues to grow. The other thing I want to mention briefly is energy management system market. So again, as far as energy management systems, and now we're talking about things like, the sophisticated software, BAS, and those types of systems that are out there. Even some of them now are more sophisticated when you get into fault detection diagnostics and some of the other things that are being added within that thing. We can call it monitoring based commissioning, other aspects. The global market is valued right now, or was valued last year, at 28.25 billion. The energy management system market. It's projected to reach 82.34 billion by 2030, to give you an idea. Now, what you see in the graphic is really the North American market. You can kind of see that it too is growing significantly over the next really 7 to 8 years. Okay, but that's just the North American market. So what's driving this? Well, again, global energy concerns are going to drive the adoption of energy management. Again, optimizing renewable energy sources. You're seeing more and more companies, more and more institutions basically wanting to, in some way, shape, or form, have control over a portion of their energy sources, through some sort of either on-site or through the purchase of maybe a power purchase agreement, some kind of a dedicated renewable energy source, maybe a solar PV farm, maybe some sort of a wind farm, whatever the case may be. The need to decrease carbon footprint. Again, this is a big part of most companies and institutions' sustainability management plans. It's also being driven now by the ESG to decrease the carbon footprint, reduce emissions, managing greenhouse gas emissions. The need to control energy consumption, okay? And then again, the fact that as a lot of municipalities and states out there have these mandates now for publicly advertising the efficiency of buildings to basically benchmark, well, basically establish a baseline, but then benchmark facilities and publicly advertise what those benchmarks are. And then in some cases, retro commission buildings on a 2 or 3 year cycle. Again, the need for investing in energy efficient smart buildings is more important than ever. There's a lot of data out there on the internet that's available. For example, if you go out there, this is a clip from the Energy Information Administration. They post these short-term energy outlooks. There's a lot of good information in them. They're posted out there on a at least a quarterly basis. Sometimes they'll have special ones that come out as well. And then they have a big annual one that they put out, an annual energy outlook. And it deals with various fuels. It deals with what they forecast. It deals not only with buildings, but transportation as well. It's a great source if you want to go out there and take a look as far as energy outlook. And it comes through the Department of Energy, but it's at Energy Information Administration. So final thing I want to do is talk very briefly about the EMA, Energy Management Association, and our certification, which is the EMP, Energy Management Professional. We have a technical certification that was really established by our organization to recognize individuals with the requisite experience and expertise, and that's tested by exam. We approach energy management from a commissioning-based perspective, okay? We were associated for a long time and still are. We're sister organizations with ACG, the AABC commissioning group. But our certification received ANSI accreditation and was recognized as well by the DOE and NIBS Better Buildings Workforce Guidelines in 2018. We sponsor periodic workshops, both virtually, which is online. It's a 2-day webinar, 3 hours each day, and also in person at various conferences. We just had CX Energy at the beginning of May, and we did a 1.5-day workshop there. It offers a refresher in energy management principles, a number of topics, and we worked through a number of sample problems. And we're recognized by ASHRAE in multiple states and municipalities for compliance with energy auditing, retro commissioning. Again, we're not the only certification, but we're equally recognized as well as any of the other certifications put out there by ASHRAE or AEE or other organizations as well. So if you're at all interested, I would encourage you to go on the website, take a look, and contact us for any more information that you may be interested in. So I don't know if we have any time for questions. I think I just ran it right to 2 o'clock today, but I'm more than willing to, if people have offered any questions in chat, I'll take a look at them and I will get back to you with responses. But I want to thank you. Thank you for your time today. And I've listed here my email. You can contact me at rknadler for Bob Knadler at hansen-inc.com. Feel free to offer any comments about the presentation today, ask me any questions, and I really appreciate your attendance today. Thank you very much.
Bob, thank you so much, and thank EMA for this great presentation. I would like to thank everyone for taking time out of their busy schedules to be with us today. So until next time, be safe, stay healthy, and be kind to one another. Thank you so much. Bye-bye now.